The study of exoplanets, worlds around stars other than our sun, is already a huge business, with the rate of discovery of these planets getting faster and faster. However, with the incredibly successful launch and deployment of JWST, the James Webb Space Telescope, we're about to gain a brand new view of these strange new worlds. In honor of this, let's take a look at some of the craziest exoplanets that we already know about, some of which might just be early targets for Webb. All the planets here are pretty different to the planets and conditions we see in our own solar system, but each of them has something cool going on. If you want more, I'll leave some useful links to read more about them in the description below. While none of the planets I've got here will be good candidates for life-bearing planets, the study of exoplanets in its own right is important for understanding our place in the cosmos. The discovery of extraterrestrial life, or even of a planet that's just like ours, would have profound psychological, social, and even religious consequences. Now, if we point Webb at these exoplanets, what can it see and what will we learn? Well, Webb can use a technique called spectroscopy, breaking up the light it receives from these planets into the different wavelengths that make up that light. And we can use that to learn the chemical elements that make up the planets and their atmospheres. This can tell us all about what each planet might be like and how it might be to visit them. And some of the ones with the most surprising things going on have made it into this video. Oh, one more thing before we start, but all exoplanets are super hard to image directly because they're all so faint and small, and they're always right next to a star that completely washes them out with its bright light. So unless I say otherwise, the images of the planets here will be artists' impressions, based on science and the evidence we have, yes, but still not real photographs. Let's start with an absolute belter, with the delightfully catchy name of J1407b, which is incredible not for what's happening on the surface of the planet, but for its enormous ring system that, quite frankly, puts Saturn to shame. It's a huge gas giant, about 80 times more massive than Jupiter, orbiting a star pretty similar to our own sun, except that it's about 434 light years from Earth. The Super Saturn planet was detected during its long eclipse of its star, which lasted 56 days. And of course, the standout feature here are the rings, which stretch to a radius of about 90 million kilometers. That's over half the distance from the Earth to the Sun, and around 200 times larger than Saturn's ring radius. This planet is absolutely nuts. Just look how it looks compared to its star. It takes the planet around 10 years to orbit that star, and this Super Saturn was the very first exoplanet with a ring system to be discovered by the transit method. Link to a video all about that in the description and in the card up here. We think that over the next few million years, these rings might start to coalesce into exomoons around the planet. So it might one day look a lot more like Saturn, which actually has 82 known moons. So maybe it looked like this long ago. There are some gaps already in the rings which suggest that some moons have formed, but more are likely on the way. Next up, while I'm not talking about planets that might be good candidates for life, this one sure does have the requirement for water taken care of. Meet GJ1214b. It's a mere 48 light years from us, and we think it's totally covered in water, and hence it's earned the Water World nickname. It's a super Earth, meaning it's larger than Earth, but smaller than the gas giants in our solar system. You can see it here compared with the Earth and Neptune, with our new friend the Water World in the middle. We don't yet actually know the exact color this planet would look to us, since our ocean water is only blue here when it reflects the blue sky. But we don't know what's making up the atmosphere of this exoplanet, so we don't know what color its sky would be. Luckily, it's a pretty nearby planet, and Webb will excel at taking spectra and analyzing the composition of alien atmospheres just like this. So the color of this planet is something Webb could definitely help with. From a water world to one raining rocks. How about the exoplanet WASP-178b? This hot Jupiter is about 1.3 thousand light years away, and it's chock full of silicon monoxide. The planet is tidally locked, so the same side of it is always facing its star. And this means that that side of the planet is incredibly hot, but also devoid of all clouds. Meanwhile, the dark side of the planet is a lot colder, but the intense temperature gradient leads to incredible 2,000-mile-an-hour winds. On the cold side of the planet, the silicon monoxide might cool down enough to condense into rocks that then rain out of the clouds. When silicon monoxide condenses, it forms a black, glassy-looking rock, which would be quite a sight, albeit a deadly one, to see falling from the sky. Maybe raining rocks isn't your thing, and you'd rather see actual glass fall from the sky. Well, you, my friend, are in luck. because I can also introduce you to HD 189733b. This insane world is the closest known hot Jupiter at just 64 light years away, and it actually looks like a gorgeous, serene marble in space. But the weather it feels is anything but serene. Winds of up to 5,000 miles an hour, which carry strands of molten glass, batter the planet. It's another planet whose atmosphere is full of silica, heated to 1,300 Celsius, and here it forms grains of glass. Carried by the intense winds on the planet, we have a world where it's raining glass sideways. This one, I think I'll skip on the tour, thank you very much. This planet actually orbits two parent stars, and it captures so much radiation from them that its atmosphere is slowly being stripped away into space. But it also is one of the rare planets that's been imaged directly, shown here in X-rays. On the plus side, the crazy weather and the silicate making up the planet give it a beautiful blue hue, as we see here in the artist's depictions of the planet. Webb again can peer into these worlds and confirm what the atmospheres contain, and tell us if these stories I'm telling you here are actually true. What's cooler than orbiting two stars? Well, orbiting three, obviously. We know of a whole host of exoplanets that have two suns in their sky, but we know of much fewer with three. One of the lucky few is LTT 1445a-b, which orbits one of its stars incredibly tightly, completing an orbit in about 5 Earth days. And this tight orbit means it's very close to the star and incredibly hot, at around 160 Celsius on the surface. The star that the planet orbits then itself orbits two other stars, completing the triple sun effect from the surface of the planet. This isn't totally unique though. Our nearest exoplanet neighbor, Proxima b, has the same setup, with at least one planet with a triple solar view, even during the day. It's been a wild ride, but we're reaching the end of the list for this video. But I want to end with 2 honorable mentions and then 1 exoplanet packed full of glam. First, our honorable mentions, starting with GJ504b, which in this artist's impression is a gorgeous magenta color, which actually is the color this planet would look to us, due to the large amounts of methane in the atmosphere. I wanted to mention this Jovian-like planet because it gives us a cool comparison between the beautiful artist's depiction of the planet and a direct image of the planet, because it's one of the few to be directly imaged with a telescope. As you can see, it's a little lower resolution, but still an incredible achievement. It's one of the lowest mass planets ever imaged directly, and it's also pretty far out from its sun. You can see here that it's more distant than Neptune is from our sun. To contrast with this, let's also mention WASP-12b, a similar planet, but one that reflects only 6% of the light that shines upon it. This means the planet looks almost pitch black, as seen in this awesome depiction. The planet is also being consumed by its star, and this is the first time this destructive process has been observed so clearly. In about 10 million years, the planet will likely be completely gone. Finally, it's also thought that the planet has a high carbon to oxygen content, which is rare for a gas giant like this, but it makes it similar to our final planet on the list. Once Webb is sticking its nose into the atmospheres of all these planets, we can confirm all these things, clarifying the composition of the atmospheres and hence the exact colors of the planets. Now, our final insane planet that I'd love to see Webb investigate is 55 Cancri e. This is a rocky planet, about 8 times more massive than Earth, and twice the diameter, making it a super Earth. It's not the only planet orbiting its star, but it is the innermost, and the interesting thing here is the high carbon content of the planet. This high carbon content has led to the planet being dubbed a diamond planet. The high pressure below the surface of the rocky planet might have crushed the carbon to form millions and millions of tons of actual diamond, potentially making up a significant portion, at least 1/3 of the planet. Although this diamond is totally inaccessible to us in any useful amount of time, it's still pretty cool to think about. Again, using JWST to confirm the composition of the planet is high on a lot of people's lists, just to know if there really is a world made of diamonds. Thank you so much for watching this video, and if you had fun, then please subscribe and let me know which of these planets you think is the coolest, craziest, or the best thing to point Webb at. Until next time, stay safe team. I'll see you soon. Bye!